Hello everyone, welcome to Basic Chemistry Class. Today we are going to continue with the ionization energy from the D and F block elements. If you haven't watched the previous recording, previous videos, do check the link in the description. So today we are going to start with the ionization energies of the D block elements. So over here, as you can see, uh, the D block elements, the ionized, first we need to understand what is ionization. There is a nucleus and there is an electron over there. Now, the energy needed to take out this electron from the outermost shell, we need to mention that this is the valence shell. That's called the ionization energy. If the shell is valence shell, then only we call it ionization energy. First ionization energy. Okay. So this is ionization energy we have learned way back. So higher than S block and lower than P block. So you know that the transition elements are between S and P blocks. So that's why they are called transitional elements. So they would be having the intermediate values and everything. Okay. Now the ionization energy with increase in atomic number. So that ionization energy would increase with the increasing atomic number. So if we move from scandium, like let's just write the 3D elements. So scandium, titanium, then vanadium, then chromium, then manganese. Over here, when I'm moving from left to right, the number of electrons are increasing, means the number of protons are increasing because the atomic number is increasing. If the number of protons are increasing, nuclear charge would increase. So as a result, the size would decrease and the ionization energy should increase. Okay. Now, but over here, if you just focus on the picture right now, the blue line, the green line, you can see titanium to vanadium to chromium, the values are decreasing, which is completely evident. But the point is, if you just have a look on manganese, so first, if you just look on the 3D element, the green line, titanium to vanadium to chromium, the values are decreasing, right? So if you just look into manganese, the values suddenly have a spike over here, and the iron is even higher than that. Okay, now why is this happening? So manganese is 25, so it would be argon 18, 3D 5 4s2. I told you just crisscross it, 5 on 3D, 2 on 4s. Okay, now this is a half-filled electronic configuration, isn't it? If we just look into 3D orbital, there are 5 orbitals over there. So over there, it's a, if I just put all the electrons, this is a half-filled stability. So definitely it would ask for more ionization energy. It is a stable electronic configuration, right? So half-fills are always stable. That's why they won't let the electron go out to break the stability. Okay, so that's why manganese is having a very high ionization energy, a spike than chromium. But now, why is iron higher than this? Okay, ionization energy of iron, you can see, is greater than the ionization energy of manganese. Now, what is the reason behind it? Let's check it out on the right side over here. So, see, if you remember the size trend, when you move from left to right, first the size decreases for the D block elements, and then it remains constant, almost constant, the radius. Okay, this is there in the first video. Then the value remains constant, then it increases. Now, up to chromium, it decreases. From chromium, then manganese, iron, for them, the value remains almost constant. So, the manganese and the iron's radiuses are almost comparable, but the number of protons are increasing, isn't it? When you're moving from manganese to iron. But the charge is increasing, the nuclear charge is increasing. Okay, so the density, the charge density is increasing as a result. The charge density of iron is more than manganese, the nuclear charge density. That's why the ionization energy of iron is more than manganese. Okay, size remains same, but the number of protons are increasing, so the charge density is increasing when you're moving from manganese to iron. As a result, the ionization energy is more. Okay. Now, over here, you just check the electronic configuration one more time. Okay, for chromium, it is 3D5 4s1. That's why it happens. This is a anomalous electronic configuration. Copper as well, anomalous electronic configuration. Just the last video we have talked about this. So copper is 29, should be 3D9 4s2. But because of the D block elements fulfilled stability, it becomes 3D10 4s1. Okay. Now again for copper as well, you can see the first ionization energy is not much, but it's for zinc. For zinc, what would happen? 3D10 4s2. 4s2. So it's a it's a full stability for both of the 3D orbital and 4s orbital. That's why to take an electron, there's a spike happening in the ionization energy. Now look into the palladium. Okay, the 4D series. Over there, it's an anomalous electronic configuration, 4D10 5s0. Okay, this anomalous. So all these anomalous electronic configuration are being discussed in the last video. Okay, the Because of 4D10 electronic configuration, you can see PD is also having a very high ionization energy because fulfilled stability. Now let's talk about the 5D series, the third transition series. So third transition series have 4f orbital, which has very poor shielding effect. Remember, in the last video we have talked about the screening of the shielding effect. 4f orbital. So if you remember, let me show you. If you remember, like S to P to D to F, that shielding effect becomes weaker. So Z star equals to Z minus S. Now S is called the screening effect. So 4f orbital has very poor shielding effect. In the last video, we have discussed about all these things. So as a result, the S is very low, the screening constant would be very low, the shielding effect would be very low. So Z star would be very much close to Z. So Z and Z star would be almost the same. So I can see the nuclear charge is going to be very high on the 4F on the 5D series, right? So as the nuclear charge would be high, so definitely you do understand the attraction would be high towards the electron. So because of the high attraction, the ionization energy would be high as well. Very much understandable. That's why you can see if you just have a look into the graph, you can see they are having very high values of ionization energy, very much higher than the other two series. Now, now, if you just look into it, there's a special reaction, special statement written over here. Okay, have a look. The reason behind the irregular trend in D block is shielding effect and reorganization energy. So shielding effect is something we have talked about, which generates due to transfer of s orbital to electron. So what are they trying to say? Shielding effect we are completely understandable. It's understandable. But what is this reorganization energy? Let's have a look into it. Let's say we have iron. Iron is 26. Okay, means 3d6 4s2. Right, crisscross. Now draw 3d6, then 4s2. You have seen that the D block element has pretty unorganized electronic configuration. Is it not electronic configuration? Ionization energy trend. So if I draw the 3d6 4s2 like this, now if I give ionization energy to it, the 4s electron would go out. Let's say, let's talk about Fe plus 1. Which electron would go out actually? The outermost electron, which is the 4s electron, would go out. So Fe plus 1 would look something like 3d6 4s1. Understand? Completely clear? Now 3d6 4s1. Right? This is the electronic configuration. So 3d6 4s1. Okay. But what happens is, to get the fulfilled stability and the half-filled stability all together, half-filled stability of 3d orbital and the fulfilled stability of 4s orbital, what happens is that electron takes a jump all the way to the 4s orbital. Now this is called reorganization energy. The electrons have reorganized themselves in such a way that both the orbital became stable after that. One is having half-filled, 3d is having half-filled, and 4s is having full-filled electronic configuration. So yeah, that would be it for today's video. And the next video we'll be talking about the oxidation state. And don't forget to subscribe to my channel. I'll be putting the next video shortly. Stay tuned and do subscribe to my channel. That would be it. Bye everyone.